Excited today to be sitting down with Christoph, who is the co-founder and co-CEO of Climeworks. Awesome. Well, let's just get started. So, first question: what's the role of carbon removal and specifically direct air capture in the climate solutions toolkit?
Yeah. Well, first of all, hi everyone. Nice meeting you all. And well, carbon removal and what's the role of carbon removal? Unifying all of us is net zero, right? Like all of us, like in climate tech, but also nature, we're working to achieve net zero by 2050. How do we get to net zero? With a 90-10 approach. 90% of getting to net zero is through reduction. And as we have emitted already too much as of speaking, there is a part that has to be removed from the atmosphere. And this is the 10% piece at the moment. That's what climate science assumes, is that on the journey to the transition to net zero emissions by 2050, again, 90% will be achieved with reduction and 10% will be achieved with carbon removal. And that's the role we are playing as at the moment a small industry. And put that in numbers, that's around 12 to 15 gigatons that have to be removed from the atmosphere by 2050, year on year.
Awesome. All right. Thanks for setting the scene. And I think, you and your co-founder in particular have a really fascinating story. You and Jen started Climeworks in 2009 before carbon removal made any headlines, before Stripe came out with their proposal. So what was your journey like, especially in the early days of Climeworks, to now where you're headed at scale with two commercial plants in the works?
Well, when we started, it's 1.5 decades ago. Like 2007, we started our research on capturing CO2 from the air. And how did we come about that? Like first, we were and we're still avid mountaineers, like spend time in the mountains. And the mountains are a very sensitive environment. Like a couple of degrees temperature change can make huge changes, like talking about the phase change of water, right? Like the difference between water and ice can be a degree Celsius. And there you see a lot of change. And when we were young, we spent a lot of time out there and we could feel the change. Like we had at that time printed maps and simply could not find in reality what was printed on the maps. And that was like in this young years, a very deep experience. So, and this is when we decided we want to do something for or against the rising CO2 emissions in the atmosphere. On the other hand, we are trained as engineers, and as engineers, you're always thinking in closed cycles. This is how you're trained. Like you're trained in closing energy cycles, and you're trained in closing material cycles. And we approached air capture at that time really not from like climate science saying we need that, but rather from a very like logical point of view, that thinking about it like we as humans, we emit CO2 into the atmosphere, but we're simply not taking it back. So we don't have a closed carbon cycle established for all the CO2 we're dumping in the air. And this simply felt wrong to us. And then by chance, we found a research program on air capture and said, well, that's it. That's a huge topic. It felt like a huge topic at that time. We want to devote our time on that and then get going first through university research. And soon we had very promising results. And well, at that time, unfortunately, very little public funding was available for air capture, almost nothing. And we had to start a company very early on to find investors who with equity helped us to essentially pay our salaries early days and pay our research on air capture, which was then in the year 2009 when it all went going.
Yeah, that's a fascinating story. I feel like you both saw the writing on the walls in the early days before a lot of the demand now has scaled. When do you think was kind of the inflection point in terms of Climeworks' story from the research and lab scale days to now where you are on the kind of demonstration and commercialization story?
Right. Well, there were a couple of really important points. Like a very, very important point for us was 2014. This was the first time when we moved from lab to environment. Like this was the very first time when we put a machine in the atmosphere, like not only for a day of testing, but like throughout a year to collect data. And that helped us a lot to calibrate our models and our engineering. And based on that, in 2017 was the next very, very important milestone, is when we commissioned the first commercial plant actually sitting in Switzerland, surfing CO2 to a greenhouse farmer who's injecting the CO2 in the greenhouse to enhance plant growth. And on the other hand, supplying CO2 to the Coca-Cola company for beverage carbonation. Those were early markets, platforms to get it going. And that plant received a lot of visibility. And then finally, the most important point, putting really a lot of wind in our sails, was 2018, when the IPCC released their special report on 1.5 degree warming, where for the very first time, the scientific community communicated with consensus, like in the very prominent IPCC report, that carbon dioxide removal from the atmosphere is needed in order to achieve climate targets, and that actually all modeling scenarios, like without any exclusion, leading to the 1.5 degree warming target, assume carbon dioxide removal on a massive scale. And this report really triggered a lot of momentum over the last 4 years.
Yeah, definitely. And I want to come back to what you said. The target is 10 to 15 kind of gigatons by 2050. Your target specifically is 1 gigaton by 2050. What needs to be true in order to get there? What are the key strategic areas that you're all really thinking about that need to go well in order to get to that scale?
Well, that's our vision: inspire 1 billion people. And why we're having that vision is to really start a mass movement for carbon dioxide removal, like generally, and air capture specifically. Like, we're not getting to gigatons if we stay one company doing that. Like, we need a whole ecosystem to think air capture. What do I want to express with that? Think about the early days of renewable energy, like solar technology, right? There were so many things required to scale. Like in the last 20 years, solar scaled by 1000x. And there were so many, like, it was not one company driving that scale up. It was like a whole ecosystem driving that scale up. That was like policy with feed-in tariff programs in like California, Spain, Japan, Germany, early days. It was, of course, technology OEMs providing the technology, but also very importantly, supply chain, right? Like a supply chain that committed to solar technology and said, hey, we believe that this will be a new industry, and we are producing parts and components to be used in solar plants specifically for that application. And at the moment in air capture, it's still the other way around. Like, of course, there is supply chain, but we are rather asking the supply chain to produce parts according to our specs. And there are no suppliers yet out there producing pumps or heat exchangers or you name it, like fans, you name it, designed only for or optimized for air capture. So again, a whole ecosystem and a whole industry has to come together to get to the gigaton. On top of that, well, there are a couple of metrics we need. Like, we need a lot of energy to capture CO2, no matter where from. Like, whether you capture it from the stack or from the air, you always need energy. And we on our part want to use renewable energy. So of course we also need deployment of renewable. But in comparison to what is happening anyway, this is all like small single-digit percentage fractions of what needs to happen in the energy transition anyway until 2050.
That's an interesting point on the needing kind of the whole ecosystem of supply chain to come together, similar to the solar industry, in order to scale this industry. That seems like one kind of critical barrier. What are some other critical barriers when it comes to scaling DAC around, demand, regulation? What are some of those key kind of gating points that you're looking to, that you're hoping the ecosystem will reach when in order to get to that 10 to 15 gigatons by 2050?
Yeah, well, at the beginning, there's the market. And if you have a market, of course, I'm oversimplifying, but everything else will fall in place. And at the moment, carbon removal obviously is a new technology. And on top of that is a completely new market. So in like in this matrix where to put startups, like high risk, high opportunity, we're in the very top right, where we both have like new market and new tech. And exactly what you alluded to, Kim, like the market is, for me personally, and the experience we made, it's really the trigger to get things going. Like once you can show that there is a market and market interest for the product you're producing. In our case, it's carbon dioxide removal as a service that we're offering to people and companies. Like once you can show this is existing, you can convince investors to put money on the table to further scale. And at the end of the day, build assets, like build infrastructure that is pulling carbon from the atmosphere. And like this is sort of the scale-up journey we have taken, and that's the scale-up journey that I do believe will be the case for the next 10 years or until end of this decade to be in place, that market triggers investment triggers infrastructure build out, and infrastructure build out triggers more market. So this sort of goes in step functions, and we're seeing that, like the first plant we built in Iceland, we call it Orca, created market interest, actually more market interest than the plant could serve, and based on that we scaled. So we saw exactly this, that based on customer demand we were able to raise funds and to build the next plant, and now we're again in the phase to collect sufficient customer demand and market demand for the next generation plant to again trigger financing and move ahead. And now I'm confident that the next 10 years will be, let's call it bridged, or will be doable with a private market. And thereafter we clearly need a compliance market for air capture to become really large. Like, or in my personal point of view, I do think that scaling from where we're today to million-ton carbon removal by end of this decade is feasible with private markets. But going from million tons per year to gigatons will require the public domain to kick in with compliant market type of things for air capture.
Yeah, those are super interesting points. I want to dig a bit deeper on the financing and the investment side, because I think it's we write about the climate capital stack a lot in CTVC, and I wonder, what's kind of your perspective on the capital stack or the different financial mechanisms that are available for financing these, CapEx, really large DAC projects and facilities.
Yeah, that's really the most relevant part of all of them, is how are you financing those assets. And at the moment we've been equity financing our assets and then refinancing, or at least trying to recover from market activity. Now the one thing air capture or this industry has to manage is to transition from equity financing of infrastructure to like standard project financing, and that won't happen overnight, right? Like if like currently there are no standards how to do diligence, for example, air capture plants, where this is like state of the art. And we talked about solar technologies before. Probably every large asset manager can, or at least those dedicated to solar investments, for them it's a piece of cake to do diligence a potential solar park or solar investment. And that's not the case for air capture. There are like no examples out there where to look at. And this is what we're working on at the forefront by building infrastructure and also giving investors the chance to do diligence and to get to know this industry. And there a couple of boxes have to be ticked, like the market, what we discussed before, of course the technology, also supply chain, what we discussed before. And now you ask concretely about the stack. How can the stack look like? Clearly the stack in the future will also have an equity contribution, and maybe some preferred equity contributions, as well as hopefully the largest share being debt contributions from asset managers, like for example, infrastructure managers, where many out there, or bigger asset managers who currently maybe hold assets in other parts of the industry, but on the route to net zero and decarbonizing, had an interest in moving some assets from rather traditional infrastructure to more like climate tech infrastructure or air capture infrastructure in the future, and over time want to get to know the space and devote more and more capital over time.
That makes a ton of sense. Wanted to switch gears from financing a bit here to go-to-market and business model. And I think Climeworks has a really interesting, one of your go-to-markets is selling B2C, selling credits directly to consumers. And I think you're one of the only DAC companies, at least, that does that. What was the thinking? What was the strategy behind the B2C model?
Well, it was... I'm meeting so many people, and every time I'm telling people about the opportunity or the chance to get CO2 back out of the air, typically people are excited and said, "Oh wow, this is amazing! Is there a way I can contribute?" And most, like, before we started the model, we had to answer this question with a no, which was always unfortunate because I thought there's like so much energy out there. And that was essentially the thought that triggered the B2C model. Also a bit like sometimes I say, or sometimes running into people who also feel a bit desperate and who want to act. So I said, I want a vehicle to democratize climate actions. I want to give people a chance to act if they wanted to act, right? And that was also in the context of what we discussed before, like starting a mass movement, engaging people, like educating people about this new field. And there this model was an interesting thought, and it proved to be a very successful model. Like today we're having more than 16,000 pioneers, as we call them, Climeworks pioneers, removing CO2 from the atmosphere permanently in their name, and they're using that for the unavoidable part of their emissions. Clearly they're following reduction efforts, but all of us, no matter what we do, will be sitting on a pile of unavoidable or hard to abate emissions. And already 16,000 people out there are removing that with Climeworks.
Yeah, that's a fascinating story. Hopefully after this, we'll get some more folks from the SOSV Summit to purchasing Climeworks credits. Awesome. I know we only have a few minutes left, so I definitely want to hit on the topic of standards and MRV. And I noticed a few weeks ago, you, along with CarbFix, announced the world's first full chain certification methodology validated by DNV for direct air capture and underground mineralization storage. What does this mean? How do you think about MRV and standards in carbon removal in general and specifically direct air capture and storage?
Standards are a big thing for carbon removal and air capture. Like you can't see CO2, you can't smell CO2. We're putting CO2 in the ground, so it's all like essentially it's all about a standard, right? The only thing that creates, so to say, the product for the market is the standard. And in such, it's so important to have it. And in such, I'm so happy that we were able to pioneer that with our partners CarbFix and with DNV. Now, the second aspect is there's no broadly accepted definition of what carbon dioxide removal is or what a negative emission is. And we hope, of course, that with the standard we put out, that we're able to inspire how standards in the future could look like. What we are standing up for and what our standard is based on is durability. That's something important, right? Like if you take carbon from the atmosphere, you better make sure it stays in the ground for a very long time to have the climate impact that we all want that it has, and also to be additional, right? It has to be additional carbon removal from the atmosphere that wouldn't have happened otherwise, etc. So there are a couple of things that we feel are extremely important and should flow into all standards. On top of that, there are a couple of Climeworks specific things. Like, for example, I mentioned before that air capture or carbon capture in general always needs energy. We want to make sure that we use renewable energy for that. Why so? We think it's very catalytic, like those two can work together. We can take off energy when the grid can't take it. So actually, like air capture is not stealing energy from renewables, but it's rather catalyzing investments and buildup of further renewables. Also, like the permanent storage aspect, we at Climeworks feel is a very crucial one for carbon dioxide removal. So I hope that with the actually if we open sourcing the standard, everyone can look at it. You can find it on our website, and I really hope that it inspires other companies for standards, but also the public domain. When the public domain defines what a negative emission or carbon dioxide removal is, takes a look at this standard.
Awesome. I think that's perhaps a good place to end in terms of the call to action on needing better standards, open sourcing standards to create that foundation for direct air capture and carbon removal in general to really scale. Well, congrats on everything that Climeworks has achieved so far. Really fascinating to hear the story, especially starting at a time when carbon removal and direct air capture weren't really recognized as the necessary tools that they really are. And all the progress that you've made on the commercialization plans, as well as on standard setting and leading the charge really for direct air capture at scale. So congrats on everything. Super excited to chat with you today and have you as part of the summit.
Thank you, Kim.